Have you ever looked at a big grey building and thought it was a little boring? Well, what if I told you that building could be alive? Not alive like a person or a pet, but alive with tiny microscopic helpers that could power our world. Scientists in Denmark have just announced something truly amazing. A new type of cement that can generate and store electricity all on its own. They call it living cement, and it could completely change how we think about the places we live and work. This isn't just regular old concrete, it's a super smart material that has the potential to turn our entire cities into giant clean energy power plants. Imagine a future where your house helps power your lights. This incredible invention comes from a team of researchers at Aarhus University. They wanted to find a way to make our buildings do more than just stand there. What if our walls could act like batteries, soaking up energy and releasing it when we need it most? This idea led them to mix biology with construction, creating a material that is part cement and part living organism. It really sounds like something straight out of a science fiction movie, but it's very real. Announced in September 2025, this breakthrough is one of the coolest things happening in science right now, because it offers a new way to create sustainable energy. So, what makes this living cement so different from the stuff we're used to? Traditional cement is just a mixture of rock and water that hardens into a strong, solid structure. It's great for building, but that's pretty much all it does. This new living cement, on the other hand, has a secret ingredient that gives it superpowers. It's a biohybrid material, which is a fancy way of saying it's a mix of non-living and living things. By combining the strength of cement with the special abilities of tiny bacteria, these scientists have created something that is both strong and energetic, ready to build a greener future. The excitement around this new technology is huge, and for a very good reason. We are always looking for new sources of clean energy to help protect our planet from climate change. We have solar panels and wind turbines, but what if our buildings themselves could join the fight? This living cement could store energy from those sources or even generate its own. This means less reliance on fossil fuels that pollute our air. It represents a giant leap forward in sustainable design, where the very materials we use to build our world are also helping to save it, one brick at a time. It's a beautiful example of how science can solve big problems. So, what is the secret that makes this cement come alive? The answer is bacteria. But don't worry, these aren't the kinds of germs that make you sick. The scientists chose a very special type of bacteria called Shigella oniidensis. You can think of these little microbes as tiny electrical engineers. They have a unique and amazing ability. They can move electrons outside of their own tiny bodies. This is a very rare skill in the microbial world, and it's called extracellular electron transfer. It's like they have invisible wires that they can use to connect with their environment and pass electricity along, which is exactly what you need to create a battery. To create the living cement, the researchers carefully mixed these microscopic powerhouses into the wet cement before it hardened. As the cement set, the bacteria didn't just get trapped inside, they started to get to work. They formed intricate, connected networks throughout the material. These networks are called biofilms, and they act like a massive system of tiny electrical wires woven directly into the concrete. This bacterial highway allows electricity to flow through the cement, turning a simple building block into something that can store and release electrical charge. It's a brilliant way to use nature's own design to create brand new technology. The result is a material that looks and feels a lot like regular cement, but has an extraordinary hidden talent. On the outside, it's strong and durable, just what you need for a building. But on the inside, it's a living, breathing ecosystem of bacteria, ready to manage energy. This makes it a microbial supercapacitor. A capacitor is something that stores energy and can release it very quickly, like the flash on your camera. By using bacteria, this cement becomes a supercapacitor that is alive, making it one of the most innovative materials ever created. It's the ultimate team-up between biology and engineering. One of the coolest fun facts about Shigella oniidensis is that these bacteria are found all over the world in soil and water. They are natural parts of our planet's ecosystem. By learning from them and inviting them into our own structures, we are working with nature instead of against it. This is so much better than mining for rare materials like lithium and cobalt, which are used in today's batteries and can be harmful to the environment. This living cement uses common materials like cement and naturally occurring bacteria, making it a much more sustainable and earth-friendly solution for our future energy needs. So, how does a wall made of this special cement actually power something like a lamp? It all comes down to its ability to store and discharge electricity, just like a rechargeable battery. When the cement is charged, an electrical current is sent into it. The network of Shigella bacteria inside the cement captures the electrons and holds onto them. Then, when you need to use that power, the circuit is completed and the bacteria release the stored electrons, creating an electrical flow. In their first big test, the scientists connected 6 small blocks of this living cement together and successfully powered an LED lamp. It was a small light, but a huge moment for science. This material isn't just a neat trick, it's impressively powerful. The researchers found that their living cement could store a surprising amount of energy. They measured its energy density at about 178 watt-hours per kilogram. That number might sound technical, but it means this cement is getting close to the performance of some types of lithium-ion batteries we use today. Imagine if the walls of just one room in your house could store enough energy to power a computer server for an entire day. That's the kind of potential we are talking about. It's not just about lighting a small lamp. It's about powering our lives in a whole new way. Of course, for anything living to work, it needs to be kept alive. The scientists thought of that too. What happens if the bacteria get old and stop working? They designed a clever solution, a network of tiny microscopic tubes running through the cement like veins in a leaf. This microfluidic system can deliver a nutrient-rich liquid, a kind of food smoothie for bacteria, directly to them. This special meal contains proteins, vitamins, and minerals that can revive tired bacteria or help new ones grow. This means the cement can actually regenerate itself, getting back up to 80% of its original energy capacity. It's like a battery that can heal itself. This self-healing ability makes the living cement incredibly durable and long-lasting. In tests, it was able to be charged and discharged 10,000 times while keeping 85% of its power. That's a lot of cycles. Plus, it works in a wide range of temperatures, from freezing cold, -15 degrees Celsius, to very hot, 80 degrees Celsius, making it suitable for climates all over the world. This isn't a fragile lab experiment. It's a tough, resilient material designed for the real world. A building made from this could potentially have a never-ending energy cycle, constantly storing and regenerating its power for years and years to come, which is simply revolutionary. Now, let's dream a little. What would the world look like if this living cement was used everywhere? Imagine cities where the buildings, bridges, and tunnels are all made from this energy-generating material. The foundations of a skyscraper could act as a massive battery, storing excess solar power collected during the day to light up the city at night. Sidewalks could store the energy from the footsteps of people walking on them. We could have self-powered buildings that are completely off the grid, generating and storing all the electricity they need right within their own walls. This would be a huge step towards energy independence and sustainability. This technology offers a powerful solution to some of our biggest environmental challenges. Building with living cement would dramatically reduce our reliance on centralized power plants that often burn fossil fuels. This would mean cleaner air, a more stable climate, and quieter cities. Furthermore, it provides a green alternative to traditional batteries, which often require mining for scarce metals that can cause environmental damage and social conflict. By using abundant cement and natural bacteria, we can build a clean energy infrastructure that is truly in harmony with our planet. It's a future powered by biology, not pollution. Of course, this technology is still very new. The scientists have shown that it works in the lab, which is called a proof of concept. The next big step is to figure out how to produce it on a large scale and make it affordable enough for widespread use. There are many challenges to overcome, but the journey of 1,000 miles begins with a single step. And this first step is an incredibly exciting one. It shows us that the solutions to our future problems might be found in the most unexpected places, even inside a block of cement. It will take more research and development, but the promise is undeniable. This amazing breakthrough is a perfect reminder of the power of human curiosity and innovation. It shows us that when we combine different fields of science, like biology, chemistry, and engineering, we can create things that were once thought impossible. The idea of a living, breathing building that powers itself is no longer just a dream. It's a real possibility that scientists are working on today. It gives us hope for a future where our cities are not just smart, but also sustainable, and where science continues to light up our world in the most wonderful and surprising ways. The future is bright, and it might just be built with living cement.